Good morning, my dear students. So, welcome back to the physics class. So, as you know that in the previous class, we were discussing about the wave optics chapter. So, we discussed about some of the laws. That is what the law of refraction and the law of reflection just by using Huygens principle. So, with the help of Huygens principle, with the help of the wavefront, we have just shown how the reflection takes place and how the refraction takes place, and even we have proved that I is equal to R in case of angle of reflection. Sorry, the law of reflection. That is what I can say, that the angle of incidence is equal to angle of reflection. Similarly, my dear students, so when we come towards the law of refraction, in that law of diffraction, I just explained you that the sign of angle of incidence to the sign of angle of refraction is always equal to the constant, that is equal to the refractive index. So this we have completed. But still, we can discuss how the refraction takes place in case of prism, in case of lens, in case reflection, in case of concave mirror. See dear students, now we know already that how the refraction takes place in case of prism with the help of rays, and also you know that how the refraction takes place in the lens, that is said to be the convex lens and the concave lens, by using a rays of light. But now we are using a plane wavefront. So just by using a plane wavefront, we are going to observe what kind of the refraction is possible, how the wavefront is going to bend, and how the wavefront is going to move inside the thickness of a glass. So these are all the things we should observe. So I am just going to draw the diagrams to show that how the refraction takes place in case of prism and in case of lens, and also how the reflection takes place in case of concave mirror. So whereas in all these cases, I am just going to consider the plane wavefront. So rather than considering incident rays, I am just going to observe the wavefront, right? So here, now the first thing is prism. So I am just moving with the 3 tabs. So that is, we can take an heading, draw the refracted wavefront produced by the prism, convex lens, concave mirror, right? So sorry, but draw the refracted wavefront for prism and convex lens, and reflected wavefront for the concave mirror. So that now let us move for prism first. So I am just going to write the refracted wavefront. How the wavefront is going to refract when it passes through the prism. For that reason, I am just going to write the prism first. So let us write the prism. So this is said to be the prism, right? With an angle of a prism A. So I am just going to name the prism as ABC, right? Now my dear students, I am going to incident a ray of light, right, to the prism to observe the refraction. But here it is the case of wave optics. I am just going to incident a plane wavefront. I am just going to incident a plane wavefront. So I am just going to place a planar wavefront here. So this is said to be the plane wavefront. Let us name this plane wavefront as ABC. Here I am just going to name it as ABC alva. So adike idu name ಮಾಡ್ಕೊಂತೀನಿ PQR ಅಂತ ಮಾಡ್ತೀನಿ. So it's easy for me. Yes. Now this is the incident plane wavefront. Now if I want to write the rays of light will be in this way. The rays of light will be in this way. For a plane wavefront, the rays of light are always parallel to each other. You know my dear students, after refraction, the rays, I am not considering a wavefront, after refraction the rays are going to bend. The rays are going to bend. The rays are going to bend. Right. And form a refracted ray and give you a different kind of image, and this prism is going to bend the incident beam of light. But here we are just discussing regarding the wavefront. See, whereas when the wavefront is going to travel inside the prism, it travels differently. It travels differently for different thickness. Dear students, we have a wavefront. So at all the points which are present on the wavefront travels with a different speed inside this prism, which is having a different thickness. Why? Because you can see that this is a prism which is made up of a glass. It is having a refractive index, call it as N. But the incident wavefront is AB. What happens? When the incident wavefront is going to fall on the prism, observe carefully. This is the radar medium. This is the denser medium. The light wave is having a much speed in the radar medium compared to that of the speed in the denser medium. It means in the radar medium the velocity is more. In the denser medium the velocity is less. See, the velocity in the radar medium is greater than that of the velocity of light in the denser medium. So as the light ray travels from radar to denser medium, its velocity decreases. Even we have studied this in the ray optics chapter also. Then what happens here in this case? I just consider AB as a wavefront. Then AB is a wavefront. So its velocity is more. Its velocity is greater in the radar medium, and its velocity is less in the denser medium. So as soon as the point A of the wavefront, that is what upper end of the wavefront, reaches the prism. Here it covers a very less thickness of the prism, because here very small portion of the prism is there. Here we have a large portion of the prism. So that the upper end of the wavefront, when it as soon as reaches the prism, it travels a lesser thickness. It travels a smaller thickness of the prism, right? So that it bends with a smaller angle. It refracts with a smaller angle. But here, when we come towards the end B, when it reaches the prism, it has to travel with the maximum thickness, so it bends to the maximum extent. Here it has to travel minimum thickness, it bends to the minimum angle, whereas here at the point B it has to cover a maximum thickness, so it bends with a maximum angle. So that, my dear students, now the refracted wavefront is in this way. So I am just going to name it as A dash B dash. So A dash B dash is what? Refracted wavefront. In your examination, you may get an question on these three, that is what? Prism, convex lens and concave mirror. Write the diagram of the refracted wavefront from the prism. Draw the diagram for the refracted wavefront from the convex lens. Draw the ray diagram to show the reflected wavefront from the concave mirror. So this is what the first question. A is prism. You can write down this diagram. Then you can mention AB is the incident wavefront. In the next line, A dash B dash is the refracted wavefront. After that, take down some points. The different parts of the wavefront travels different thickness of the prism. See, while writing, pause the video and write. Full stop. The velocity of a light in radar medium is greater than the velocity of light in denser medium. Full stop. Next line. So these 2 points now, what I am saying, these 2 points are very important. So that should be written. Suppose if they ask you to explain, but almost all they never ask you to explain. Suppose if they ask you to explain, you should write these 2 main points. So write that. The upper part of the wavefront A travels minimum thickness and slow down for shorter time. Next line, the lower part of the wavefront B travels maximum thickness and slow down for longer time. Yes, full stop. Yes, these are the 2 important points that you should write in your examination. And also you should mention that AB is the incident wavefront and A dash B dash is the refracted wavefront. Now I am moving with the second one. That is what, now you may get the question like, draw the refracted wavefront produced by the convex lens. This question you may get in your examination. So what I am doing, now I am just going to write the convex lens first. So you know this. So this is said to be your convex lens. So just write out the convex lens. Right. So the convex lens is the one which is having an optic center. O. Let us name the lens with the aperture by X and Y. Now my dear students, you know that if I want to write the parallel beam of light, if I want to write the plane wavefront, I should exactly write the parallel beam of light. See my dear students, now I can write the plane wavefront. That is what? AB is your plane incident wavefront. You know, you studied in your ray optics chapter that when the two parallel rays parallel to the principal axis incident on the convex lens, after refraction they passes through the principal focus. After refraction they passes through the principal focus. So this point is taken as capital F. This you have studied already. But what happens to the wavefront now? We should discuss about the wavefront clearly. So you should be very careful. Whereas convex lens is made up of glass, whereas this is a denser medium and this is an air medium called as rarer medium. You know that again the velocity of light in the air medium is greater than the velocity of the light in the denser medium. Due to this reason, as the ray of light enters from the rarer medium to the lens, it refracts and forms the image at principal focus. Rather than considering arrays, I am just going to consider a wavefront, which is said to be the plane wavefront. I am going to name that wavefront as AB. AB is a wavefront. Now, this wavefront is moving towards the convex lens. Observe carefully. At the top of the lens, at the upper end of the lens and at the lower end of the lens, there is a very less thickness, whereas at the middle of the lens, the thickness is maximum. At the lower end and the upper end of the lens, the thickness is very less, and at the middle and at the mid part of the lens, we have a maximum thickness. Now, the upper end of the wavefront and the lower end of the wavefront, when it reaches the lens, see, I am just repeating again, the upper end and the lower end of the wavefront, the upper and the lower parts of the wavefront, when they reaches the lens, they should travel a minimum thickness. So minimum thickness ಅಂದ್ರೆ ಸ್ವಲ್ಪ ಹೊತ್ತು ಮಾತ್ರ ಲೆನ್ಸ್ ಒಳಗಡೆ ಸ್ವಲ್ಪ ಹೊತ್ತು ಮಾತ್ರ ಡೆನ್ಸರ್ ಮೀಡಿಯಂ ಅಲ್ಲಿ ಟ್ರಾವೆಲ್ ಮಾಡುತ್ತೆ. ಅಂದ್ರೆ ಯಾವಾಗ ಜಾಸ್ತಿ ಡೆನ್ಸರ್ ಮೀಡಿಯಂ ಅಲ್ಲಿ ಟ್ರಾವೆಲ್ ಮಾಡುತ್ತೋ ಅಷ್ಟು ಅದರ ವೆಲಾಸಿಟಿ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಬಟ್ ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, ಈ ಎರಡು ಪಾರ್ಟ್ಸ್ ಅಂದ್ರೆ ಮೇಲಿನ ಪಾರ್ಟ್ ಎ ಮತ್ತೆ ಬಿ ಪಾರ್ಟ್ ಏನ್ ಮಾಡುತ್ತೆ, ಈ ಅಪ್ಪರ್ ಪಾರ್ಟ್ಸ್ ಅಲ್ಲಿ ಮೂವ್ ಆಗೋದ್ರಿಂದ ಇಲ್ಲಿ ಥಿಕ್ನೆಸ್ ಕಡಿಮೆ ಇದೆ, ಮಧ್ಯಕ್ಕೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ಥಿಕ್ನೆಸ್ ಕಡಿಮೆ ಇರೋದ್ರಿಂದ ಜಾಸ್ತಿ ಹೊತ್ತು ಟ್ರಾವೆಲ್ ಮಾಡಲ್ಲ, ತುಂಬಾ ಕಡಿಮೆ ಹೊತ್ತು ಟ್ರಾವೆಲ್ ಮಾಡುತ್ತೆ. ಅಂದ್ರೆ ವೆಲಾಸಿಟಿ ಸ್ವಲ್ಪನೇ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಸೊ ಅದಕ್ಕೆ ಏನ್ ಹೇಳ್ತೀವಿ, ದ ಅಪ್ಪರ್ ಎಂಡ್ ಅಂಡ್ ದ ಲೋಯರ್ ಎಂಡ್ ಆಫ್ ದ ವೇವ್ ಫ್ರಂಟ್ that travels a minimum distance, minimum thickness in the lens and slow down for a smaller time. Slow down for a smaller time because ಇಲ್ಲಿ ಸ್ಲೋ ಡೌನ್ ಅಲ್ಲಿ ವೆಲಾಸಿಟಿ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಬೆಂಡ್ ಆದ್ಮೇಲೆ ವಾಪಸ್ ಲೇಸರ್ ಮೀಡಿಯಂ ಬರುತ್ತಲ್ಲ, ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಹಾಗೆ ಮತ್ತೆ ವೆಲಾಸಿಟಿ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ರೈಟ್. ಸೊ ಸಿಮಿಲರ್ಲಿ ಮಾಡಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ಇಲ್ಲಿ ಸ್ವಲ್ಪ ಸ್ಲೋ ಡೌನ್ ಆಗುತ್ತೆ, ಬಟ್ ಇಲ್ಲಿ ಜಾಸ್ತಿ ಸ್ಲೋ ಡೌನ್. ಇಟ್ ಮೀನ್ಸ್ ಏನರ್ಥ ಗೊತ್ತಾ, ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಿರ್ಬೇಕು ನಾನು ಹೇಳೋದ್ರಲ್ಲಿ. ಅಂದ್ರೆ ಇಫ್ ಐ ಜಸ್ಟ್ ಕನ್ಸಿಡರ್ ಒನ್ ಹ್ಯೂಮನ್ ಬೀಯಿಂಗ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ, ಓಕೆನಾ, ತುಂಬಾ ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ತೀನಿ. ಅವನೇನ್ ಮಾಡ್ತಾನೆ, ಇಬ್ರು ಜೊತೆಲೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾರೆ ಜರ್ನಿನ. ಸೊ ಜರ್ನಿನ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದಾಗ ಇಲ್ಲಿ ನೋಡಿ ಥಿಕ್ನೆಸ್ ಏನಾಗಿದೆ, ಪ್ರಿಸಮ್ನ ರೀಚ್ ಮಾಡಿದ ತಕ್ಷಣ ಲೈಟ್ಗೆ ಇಲ್ಲಿ ಜಾಸ್ತಿ ಡಿಸ್ಟೆನ್ಸ್ನ ಟ್ರಾವೆಲ್ ಮಾಡಬೇಕು, ಇಲ್ಲಿ ಕಡಿಮೆ ಡಿಸ್ಟೆನ್ಸ್ನ ಟ್ರಾವೆಲ್ ಮಾಡಬೇಕು. ಈಗ ನಾನು ಫಿಸಿಕ್ಸ್ ಪಾಯಿಂಟ್ ಆಫ್ ವ್ಯೂ ಅಲ್ಲಿ ಹೇಳ್ತಾರಲ್ಲ, ಜಸ್ಟ್ ಗಿವಿಂಗ್ ಯು ದ ಎಕ್ಸಾಂಪಲ್. ಸೊ ಇಲ್ಲೇನಾಗುತ್ತಾ, ದಿಸ್ human being actually travels a very small distance, but he has to cover a maximum distance, right? So ಏನಾಗುತ್ತೆ, ತುಂಬಾ ಲಾರ್ಜ್ ಡಿಸ್ಟೆನ್ಸ್ ಕವರ್ ಮಾಡಬೇಕು. ಜೊತೆಗೆ ಇಲ್ಲಿ ಥಿಕ್ನೆಸ್ ಜಾಸ್ತಿ ಆಗಿರೋದ್ರಿಂದ, ಇಲ್ಲಿ ಡೆನ್ಸರ್ ಮೀಡಿಯಂ ಆಗಿರೋದ್ರಿಂದ ಲೈಟ್ ರೇ ರೇಯರ್ ಮೀಡಿಯಂ ಅಲ್ಲಿ ಮೂವ್ ಆಗಿರೋಷ್ಟು ಫಾಸ್ಟ್ ಆಗಿ ಈ ಮೀಡಿಯಂ ಅಲ್ಲಿ ಮೂವ್ ಆಗಲ್ಲ. ಬಟ್ ಇಲ್ಲಿ ಥಿಕ್ನೆಸ್ ಕಡಿಮೆ ಇರೋದ್ರಿಂದ ತುಂಬಾ ಬೇಗ ಈ ಮನುಷ್ಯ ಟ್ರಾವೆಲ್ ಮಾಡಿ ಬಂದ್ಬಿಡ್ತಾನೆ. ಅಂದ್ರೆ ಈ ವೆನ್ ದಿಸ್ ಹ್ಯೂಮನ್ ಬೀಯಿಂಗ್ ಇಸ್ ಅಟ್ ದಿಸ್ ಪೊಸಿಷನ್, ಆ ಹ್ಯೂಮನ್ ಬೀಯಿಂಗ್ ಈ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ರೀಚ್ ಆದಾಗ ಈ ಮನುಷ್ಯ ಏನ್ ಮಾಡ್ತಾ ಇರ್ತಾನೆ, ಸೊ ಇಸ್ ಜಸ್ಟ್ ಯೂಸ್ ಟು ಟ್ರಾವೆಲ್ ಅ ಲಾರ್ಜರ್ ಡಿಸ್ಟೆನ್ಸ್ ವೆರಿ 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 ಸ್ಲೋಲಿ ಅಂಡ್ ಹಿ ಕಮ್ಸ್ ಟು ಸ್ಟೇ ಅಟ್ ದಿಸ್ ಪೊಸಿಷನ್. ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಅಂದ್ರೆ ಎಷ್ಟೊತ್ತು ಅವನು ಡೆನ್ಸರ್ ಮೀಡಿಯಂ ಅಲ್ಲಿ ಟ್ರಾವೆಲ್ ಮಾಡ್ತಾನೋ ಅಷ್ಟು ಅವನ ವೆಲಾಸಿಟಿ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ಈವನ್ ಇಟ್ ಟ್ರಾವೆಲ್ಸ್, ಸೊ ಅದಕ್ಕೆ ಹೇಳಿದ್ದು ದ ಪಾಯಿಂಟ್ ಬಿ travels a maximum distance and slow down for a longer time. ಅದಕ್ಕೆ ಜಾಸ್ತಿ ಹೊತ್ತು ಏನಾಗುತ್ತೆ, ಸ್ಲೋ ಆಗ್ತಾನೆ. ಅದಕ್ಕೆ ನೋಡಿ ರಿಫ್ಲೆಕ್ಷನ್ ಆಗ್ತಾ ಇದೆ, ಅವ್ನು ಬೇಗ ರೀಚ್ ಆಗ್ತಾನೆ ಈ ಪಾಯಿಂಟ್ಗೆ, ಬಟ್ ಈಸ್ ಟ್ರಾವೆಲ್ ವೆರಿ ಲೆಸ್ ಟೈಮ್, ಅಂದರೆ ತುಂಬ ನಿಧಾನಕ್ಕೆ ಟ್ರಾವೆಲ್ ಮಾಡ್ತಾನೆ. ಸೊ ಎರಡೂ ಪಾಯಿಂಟ್ಸ್ನ, ಸೇಮ್ ಫೇಸ್ ಇರೋ ಪಾಯಿಂಟ್ಸ್ನ ನಾನು ಜಾಯಿನ್ ಮಾಡಿಕೊಂಡಾಗ ನನಗೇನು ಬರುತ್ತೆ, ಪ್ಲೇನ್ ವೇವ್ ಫ್ರಂಟ್ ಬರುತ್ತೆ. ಸೊ ಅದೇ ಥರನೇ ಸ್ವಲ್ಪ ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್. ಸೊ ಇಲ್ಲೇನು ಮಾಡ್ತೀವಿ, ಸೊ ಇಲ್ಲಿ ನಮಗೆ ಥಿಕ್ನೆಸ್ ಕಡಿಮೆ ಇದೆ. ಸೊ ಥಿಕ್ನೆಸ್ ಕಡಿಮೆ ಇರೋದ್ರಿಂದ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ವೇವ್ ಫ್ರಂಟ್ ಎಷ್ಟು ಕಡಿಮೆ ಹೊತ್ತು ಟ್ರಾವೆಲ್ ಮಾಡುತ್ತೆ. ಇಫ್ ಇಟ್ ಟ್ರಾವೆಲ್ಸ್ ಅ ಲೆಸ್ ಟೈಮ್, ಸೊ ಇಟ್ಸ್ ಸ್ಪೀಡ್ ರೆಡ್ಯೂಸಸ್ ಫಾರ್ ಸ್ಮಾಲರ್ ಟೈಮ್. ರೈಟ್. ಸೊ now let us observe that. So the upper end and the lower end of the wavefront, upper end and the lower end of the wavefront. See, when it reaches the convex lens, they travel a minimum thickness, because kadime ida travel minimum thickness. Minimum thickness, if they are traveling, it indicates that they slow down for smaller time, less time. So they slow down for less time they slow down agutte. So they comes to this position. They slow down this position. But when the mid portion of the wavefront reaches the convex lens, so here at the midpoint of this, that is what, at exactly the center of the lens, it has to cover maximum distance. If it is covering maximum distance, it has to slow down its velocity for longer time. So it slow down for longer time. So it slow down for longer time. It indicates that it reaches only this position when others are at this position. So these 3 points are the points with the constant phase. So because it's the same phase, so I am going to join those points. So get a wavefront called as spherical wavefront. So let us give the name A dash B dash. So when we observe the refraction through the convex lens, AB is the incident plane wavefront, whereas A dash B dash is the refracted spherical wavefront. So here you can observe this is a spherical refracted wavefront, right? So whereas all the rays, all the wavefronts are going to converge at the point F. So now take down this, when AB is an incident plane wavefront and A dash B dash is the refracted spherical wavefront. Full stop. In the next line, see, I am not going to repeat the same points which you written in the prism. ಮತ್ತೆ ಅದೇ ಪಾಯಿಂಟ್ ನಾನು ಬರೆಸಲ್ಲ, ಮತ್ತೆ ಎರಡು ಪಾಯಿಂಟ್ಸ್ ಸ್ಕಿಪ್ ಮಾಡಿ ನಾನು ಬರೆಸ್ತಾ ಇದ್ದೀನಿ. ಟೇಕ್ ಡೌನ್ ದ ಫಸ್ಟ್ ಪಾಯಿಂಟ್. The upper and the lower parts of the wavefront travel minimum thickness and slow down for shorter time. Next point, the middle part of the wavefront travels maximum thickness and slow down for longer time. Full stop. Next point. Another point we are adding here. Why? Because it is spherical portion. Due to this, tilting of a plane wavefront after refraction at the edges forms spherical wavefront and converges at principal focus. Right. So, ಈ tilting ಆಗೋದ್ರಿಂದ ರಿಫ್ರಾಕ್ಷನ್ ಆದಮೇಲೆ ನಮಗೆ ಸ್ಪೆರಿಕಲ್ ವೇವ್ಫ್ರಂಟ್ ಬರುತ್ತೆ. ಅದೆಲ್ಲ ಎಲ್ಲಿ ಕಾನ್ವರ್ಜ್ ಆಗುತ್ತೆ? ಪ್ರಿನ್ಸಿಪಲ್ ಫೋಕಸ್ ಅಲ್ಲಿ. ಸೊ ದಿಸ್ ಇಸ್ ಅಬೌಟ್ ದ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್. ನೌ ಲೆಟ್ us move towards the discussion of concave mirror. That is what? How to draw the reflected wavefront for a concave mirror. Okay, correct. So I'm just moving towards the discussion of concave mirror. XYZ to be the concave mirror. So this concave mirror is having the principal axis with a pole, with the center pole P. Right. Now what I am doing, I am going to insert a plane wavefront. It means parallel beam of light is going to incident on this mirror. So I am just going to write a plane wavefront with the name AB. So what is AB? AB is the incident plane wavefront. AB is the incident plane wavefront. What happens now? You know, my dear students, it is a concave mirror. It is after reflection, the rays of light are going to converge at a point called as principal focus. So here the rays after refraction. So they just after reflection from the concave mirror, they meet at a point called as principal focus. Now, but I want to write the which one? I want to write the wavefront for this. How to write the wavefront? So observe here, this is a mirror said to be the denser medium, whereas this is a rarer medium called as the air medium. It is called as a rarer medium. You know that the velocity of a light in the rarer medium is greater than the velocity of light in the denser medium. See what happens now? This is a plane wavefront. See, you can observe these two spherical curves. E ends I observe madbodu. So enagutte this part of the wavefront and this part of the wavefront. It means the two upper ends of the wavefront when they reaches the concave mirror. At these two spherical edges of the concave mirror, so what happens? They reflect, right? They reflect and slow down for a shorter time, They slow down for a shorter time. They slow down for a shorter time. But you can even observe, my dear students. In observe ಸೊ ಯಾವ ಥರ ಇಲ್ಲಿ ಟ್ರಾವೆಲ್ ಮಾಡುತ್ತೆ ಅಂತ ಹೇಳಿಬಿಟ್ಟು ಬೇಕಾದ್ರೆ ಒಂದ್ಸಲಿ ಬರ್ಕೊಂಡ್ಬಿಟ್ಟಿನ ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ರೆ ಇನ್ನ ಈಸಿ. ಫಸ್ಟ್ ಯು ಕ್ಯಾನ್ ರೈಟ್ ಇಟ್ ಆ್ಯಂಡ್ ಕ್ಯಾನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇಟ್. ಸೊ ನಿಮಗೆ ಗೊತ್ತಿರೋ ಲೈಟ್ ರೇ ಇದೆಲ್ಲ ಆಗಲೇ ಹೇಳಿದ್ದೀನಿ 2 ಪಾಯಿಂಟ್ಸ್. ವೆಲಾಸಿಟಿ ಆಫ್ ಲೈಟ್ ಈಸ್ velocity of light in the rarer medium is greater than that of the velocity of the light in denser medium. Now let us move on the next one. ಅದೆಲ್ಲ ಬರೆಯೋದು ಬೇಡ. ಸೊ ಬಟ್ ರೈಟ್ AB is a incident plane wavefront, whereas ಇನ್ನು ನಾವು reflected wavefront ಬರ್ದಿಲ್ಲ. ಸೊ A dash B dash is the reflected spherical wavefront ಅಂತ ಬರ್ಕೊಳ್ಳಿ. ಸೊ ತೋರಿಸ್ತೀನಿ ನಾನು, ಯಾಕಂದ್ರೆ ನೀವು ಬರ್ಕೊಂಡ್ರೆ you will get an idea to explain it. So write down the point, so that write down that the plane wavefront AB when it incident on the concave mirror, the middle of the wavefront has to travel largest distance to P before it gets reflected. Full stop. Next point. But the peripheral portion has to travel the smallest distance before getting reflected. Full stop. In the next one, therefore the reflected wavefront is converging spherical wavefront. Full stop. Yes. So my dear students, it is similar to that of convex lens, but it is refraction and reflection understand. So observe ಮಾಡಿ ಈ ಪೋರ್ಷನ್ ಅಲ್ಲಿ ನಾನು ಆಗಲೇ ಹೇಳಿದೆ ನನ್ನ ಪಾಯಿಂಟ್ ನ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿದೆ, ಬಟ್ ಟು ಮೇಕ್ ಯು ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಕ್ಲಿಯರ್ಲಿ ಮತ್ತೊಂದ್ಸರಿ ಸೆಂಟೆನ್ಸ್ ನ ಬರ್ಸಿದ್ದೀನಿ. ಪಾಸ್ ಮಾಡಿ ಬರ್ಕೋಬೇಕು, ರೈಟ್? ಸೊ ಫಾಸ್ಟ್ ಅಂತ ಅನುಮಾನಕ್ಕೆ ಹೋಗಬೇಡಿ. ಸೊ ಪಾಸ್ ಮಾಡಿ ಬರೀಬೇಕು. ಸೊ ಐ ಕ್ಯಾನಾಟ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಇಟ್ ಸ್ಲೋಲಿ, ಅದು ವಿಡಿಯೋ ಸುಮ್ಮನೆ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಇಟ್ ಇಸ್ ನಾಟ್ ಕರೆಕ್ಟ್. ನೀವು ಪಾಸ್ ಮಾಡಿ ಬರ್ಕೊಂತ ಹೋಗ್ಬೇಕು. 2 ಲೈನ್ಸ್ ಸ್ಕೇಲ್ಸ್ ಇರುತ್ತೆ, 2 ವರ್ಡ್ಸ್ ಪಾಸ್ ಮಾಡಿ ಬರೀಬೇಕು. ಆನ್ ಮಾಡ್ಕೊಂಡು ಮತ್ತೆ ಬರೀತಾ ಹೋಗಿ. So like A and B are the two ends of the wavefront, right? Here the ends of these two ends of the wavefront reaches the concave mirror. See, whereas and see in a shorter time, the reaches this concave mirror in a shorter time and reflects back. But the mid portion of the wavefront has to cover a larger distance. It has to take a more time to reach the point P. So that my dear students, before this mid portion reaches a point P, this point A and point B of the wavefront reaches the mirror and reflects back. Right? But when they reflect back, even the mid portion of that reaches the point P, and then it is going to reflect back slowly. Why? Because ಇಲ್ಲಿ ಬೇಗ ನಿಮಗೆ ರಿಫ್ಲೆಕ್ಷನ್ ಕಾಣುತ್ತೆ. ಯಾಕೆ ಅಂದ್ರೆ ಕಮ್ಮಿ ಡಿಸ್ಟೆನ್ಸ್ ಟ್ರಾವೆಲ್ ಮಾಡಬೇಕು. ಇಲ್ಲಿ ಅಟ್ ದ ಮಿಡ್ ಪೋರ್ಷನ್ ಹಿಯರ್ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಟ್ರಾವೆಲ್ ಲಾರ್ಜರ್ ಡಿಸ್ಟೆನ್ಸ್, ಅಲ್ಲಿ ರಿಫ್ಲೆಕ್ಷನ್ ತುಂಬಾ ಲೇಟ್ ಆಗಿ ಇಲ್ಲಿ ಕಾಣುತ್ತೆ. ಸೊ ಹಾಗಾದ್ರೆ ಈ ಪಾಯಿಂಟ್ಸ್ ನಾನು ಏನಾದ್ರು ಜಾಯಿನ್ ಮಾಡಿದ್ರೆ ಐ ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ದಿಸ್ ಸ್ಫೆರಿಕಲ್ wavefront. It is what? A dash, B dash. So that is said to be the converging wavefront. After the reflection, the wavefronts are going to converge at a point called as principal focus. Yes, this is all about the diagram. So this is about, definitely you may get the question in 2 months, right? And now see in the numericals and arithmetics while I am discussing, so adali question number 16, right? So whereas I discuss ಮಾಡಬೇಕಾದ್ರೆ, so we have did one simple mistake. So ಏನು ಅಂದ್ರೆ, so z minus 0.035, question number 16, right? So 0.035 plus 0.05 is equal to 0.6 by r ಅಂತ ಇದೆ, right? So ಇದನ್ನ ನಾವು ಸಬ್ಸ್ಟ್ರಾಕ್ಷನ್ ಮಾಡ್ಕೊಂಡ್ರೆ will get 0.014, ಬಟ್ ಅಲ್ಲಿ ನಾವು ಏನು ಮಾಡಿದ್ವಿ 0.018 ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ಕೊಂಡಿದ್ದೆ. ಒಂದ್ಸಲಿ ಅದನ್ನ ಏನು ಮಾಡ್ತೀರಾ, ರೆಕ್ಟಿಫೈ ಮಾಡ್ಕೊಳ್ಳಿ, ರೈಟ್? ಸೊ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಆದಾಗ r is equal to 0.6 divided by 0.014. So divide ಮಾಡಿ, write the answer for the radius of curvature with SI unit. ಮಾಡ್ತೀರಾ ಅನ್ಕೊಳ್ತೀನಿ. ಸೊ ಒಂದು ಸಿಂಪಲ್ ಮಿಸ್ಟೇಕ್ ಆಗಿದೆ, 1.8 ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿದ್ದೀನಿ rather than substituting 1/4. Okay, just make it a rectify in your notebook. Now after the completion of this topic, we are moving towards Doppler effect. In your first PUC, you might have studied Doppler effect, right? So that Doppler effect is exactly related to the sound. Even you have derived 3 cases. That is what, when the observer is stationary, but the source is moving towards the observer, towards the stationary observer, or the source is moving away from the stationary observer. These 2 are the cases. Again, the source is stationary, whereas the observer is moving away from the stationary source, or the observer is moving towards the stationary source. Even we can consider that both are moving. Dear students, this thing we have studied in case of sound. This thing we have studied in our first PUC. This concept is exactly based on sound. But now we can apply the same kind of the Doppler effect in case of the light also. Light allu kuda we can apply this Doppler effect. Then what is a Doppler effect? Ilvalle neltadri. Doppler effect is an apparent change in the frequency anta heltidri, right? You are going to give the same apparent change in the frequency of sound waves again, but the apparent change in the frequency of light due to the relative motion between the source and the observer. Same definition that what we given the definition in case of sound wave. So now let us define what is Doppler effect in case of light. So in case of light, I am just explaining you what is the definition for Doppler effect. See my dear students, there is no need to explain more. Why? Because you already defined the Doppler effect in case of sound. It is apparent change in the frequency of the sound wave in case of sound chapter, in case of the waves chapter. So what happens, see sometimes even in that first PUC we have did some numericals related to the train, which exactly gives that the train is moving towards the stationary observer on the platform, or the train is moving away from the observer on the stationary observer who is standing in the platform. So my dear students, so you know that you might have experienced when the ambulance is just moving, that is what near to your home. Suppose you can, so it is just an imagination. Imagine that the ambulance is moving in front of your home. So what happens now? When it just reaches you, the frequency of the sound increases. When it moves away, the frequency of the sound decreases. But actually, my dear students, the frequency of the sound produced by that ambulance is that said to be the actual frequency or the true frequency. And a van into sound ಅಥವಾ frequency ಏನಿರುತ್ತೆ ಸೇಮ್ ಇರುತ್ತೆ. ಬಟ್ ನಮಗೇನಾಗುತ್ತೆ, ಡ್ಯೂ ಟು ರಿಲೇಟಿವ್ ಮೋಷನ್ ಅಂದರೆ ಮೇ ಬಿ ಅಬ್ಸರ್ವರ್ ಮೂವ್ ಆಗಿರ್ತಾನೆ ಅಥವಾ ಸೋರ್ಸ್ ಮೂವ್ ಆಗಿರುತ್ತೆ. ಡ್ಯೂ ಟು ದ್ಯಾಟ್ ರಿಲೇಟಿವ್ ಮೋಷನ್ ನಮ್ಗೆ ಏನು ಅನ್ಸುತ್ತೆ, ಸಮ್ ಚೇಂಜ್ ಇದೆ, ಏನೋ ಚೇಂಜ್ ಇದೆ, ಫ್ರೀಕ್ವೆನ್ಸಿ ಕಡಿಮೆ ಆಯಿತು, ಫ್ರೀಕ್ವೆನ್ಸಿ ಜಾಸ್ತಿ ಆಯಿತು. ಇಲ್ಲೇನು ಹೇಳಿದ್ವಿ, ಫ್ರೀಕ್ವೆನ್ಸಿ ಜಾಸ್ತಿ ಆಯಿತು ಆ್ಯಂಡ್ ವಿ ಸೆಡ್ ದಟ್ ದ ಫ್ರೀಕ್ವೆನ್ಸಿ ಕಡಿಮೆ ಆಯಿತು. ಸೊ ದೀಸ್ ಟೂ ಥಿಂಗ್ಸ್ ಶೋಸ್ ಯು ದಟ್ the apparent change in the frequency. It is not the real change in the frequency, it is an apparent change. Why the apparent change? Due to the motion, due to the relative motion present between observer and also the source. Similarly, in case of the Doppler effect, we can explain this with the help of light ray also. That is what the definition of a Doppler effect is: the apparent change. The apparent change in the frequency of light wave, right, in the light wave due to the relative motion between due to the relative motion between which one? Source and observer. ಈ ಎಂತ source? Light source. Because ಅಲ್ಲಿ sound source ಅಂತ ಕರೀತಾ ಇದ್ದೀವಿ. Yes. So this is said to be the Doppler effect. But in this Doppler effect, we have two kinds of shift. One is said to be the red shift, and another one shift is said to be the blue shift. So even I will just define you what is red shift and what is blue shift. Before that, take down the heading and take down that definition, my dear students. So next, let us take heading red shift. So in red shift yavaga barutte andre, see, I said you that there is a relative motion between the source and the observer. Assume that another light source is that, but here there is an observer. So somewhere under, so in front of me, like you can observe that this is a board, right? This is said to be this is said to be the stationary source. Sorry, this is said to be the stationary observer. Board na observer anta consider ಮಾಡ್ತೀನಿ. So I am a source, I am producing the light. If I am just moving away from this observer, it means this board is an observer, this board is not moving, but I am the source, but I can move. So that when I just move away from this observer, what happens? The light wavelength shifts from the shorter wavelength region to the greater wavelength region. Which one is a larger wavelength? Which color is having a greater wavelength? So red color is the one which is having greater wavelength. So that the ray of light shifts from the shorter wavelength to the larger wavelength is said to be the red color. So this kind of shift, this kind of apparent shift is called as red shift. And the when case when this is possible, this red shift is possible when a source moves away from the observer. But when this blue shift will come, so when this blue shift will come, see here, see the opposite. So it means when the source moves towards the observer. See, this is an observer, okay? I'm the source. If I just move towards this observer, what happens? The wavelength of a light shifts from longer wavelength to the shorter wavelength region. Which one is having a shorter wavelength? That is a blue color. So it is said to be the blue shift. So take down the definition for red shift and the blue shift. Red shift is it can be written as when the source of light moves away from the stationary observer, the wavelength of the light shifts from the shorter wavelength to the largest wavelength is called red shift. Next, blue shift. So when the source of light moves towards the observer, the wavelength of the light shifts from the largest wavelength to the shortest wavelength called blue shift. Full stop. Now let us write a simple formula which gives you the Doppler effect for light. My dear students, you know already that the Doppler effect, that is what? Apparent change, that is the apparent frequency delta f divided by true frequency f. So because we aim at f minus f naught, right, divided by f. Right? So my dear students, so on the f2 minus f1 divided by f, so apparent change in the frequency represent in case of the first PUC so delta f by f is a true frequency of light and the original frequency of light. Delta f is apparent frequency of light, then which is equal to v radial divided by c. C is the velocity of light in air. So now what is mean by v radial then? It may be the question that you may get in your mind. So my dear students, this is the velocity of the light between the line joining from observer and the source. But write this formula, take down the heading. So the formula for the Doppler effect. Next line, write the formula which was present here. But please be careful. This v radial becomes plus or minus. Right? Yes. But put in next line only. Plus or minus yake anta explain ಮಾಡ್ತೀನಿ, but first write that as. So where f is a actual frequency, delta f is the Doppler shift. In the next line, c is the velocity of light in air or vacuum. In the next line, v radial is the component of source velocity along the line joining the observer and the source. Yes. See my dear students, so as I said, you will explain in the head. So yavaga plus agutte, yavaga minus agutte anta kuda heltini. So please be careful. Observe madi. Dear students, please be careful. See, this is said to be the shift. This is said to be the Doppler shift. This is said to be the actual frequency. This is the velocity of light in air. Then what is v? See. ಅದರ್ವೈಸ್ ಬಿ ರೇಡಿಯಲ್ ತುಂಬ ಈಸಿಯಾಗಿ ಹೇಳ್ಬೋದು, ವೆಲಾಸಿಟಿ ಆಫ್ ಸೋರ್ಸ್ ಅಂತಾನು ಹೇಳ್ಬೋದು. ಇಟ್ ಮೀನ್ಸ್ if I just consider that yes, this is said to be the bulb, right? If I just consider this is said to be the bulb, so this is considered as a source. Illenagilla ನಾನು ಆಗಲೇ ಹೇಳಿದೆ, when the source moves towards the observer or when the source may move away from the observer. So it means the source is moving. It means source is having its velocity. So ಇಲ್ಲಿ ನಾವು ಏನು ಮಾಡ್ತೀವಿ, ಅಬ್ಸರ್ವರ್ ಅನ್ನು ಬರೀತೀವಿ. This is said to be the observer. The velocity of the source between the line joining between the source and the observer is called as the radial velocity. That is the velocity of the source. Velocity of the source. ಅಂದ್ರೆ ಈ ಸೋರ್ಸ್ ಏನಾಗುತ್ತೆ, ಟುವರ್ಡ್ಸ್ ದ ಅಬ್ಸರ್ವರ್ ಕೂಡ ಮೂವ್ ಆಗ್ಬೋದು, ಆರ್ ಅವೇ ಫ್ರಮ್ ದ ಅಬ್ಸರ್ವರ್ ಕೂಡ ಮೂವ್ ಆಗ್ಬೋದು. ಬಟ್ ಯಾವ್ದ್ರ ಮಧ್ಯೆ ಇರುತ್ತೆ ವೆಲಾಸಿಟಿ, ಬಿಟ್ವೀನ್ ದ ಲೈನ್ ಜಾಯಿನಿಂಗ್ ಬಿಟ್ವೀನ್ ದ ಸೋರ್ಸ್ ಅಂಡ್ ಅಬ್ಸರ್ವರ್. ಅದಕ್ಕೆ ಇದನ್ನ ಬಿ ರೇಡಿಯಲ್ ಅಂತ ಬರೀತೀವಿ. ಸಪೋಸ್ if the light source away from the observer move ಆದರೆ, when it moves away from the observer, then V radial becomes positive. V radial becomes positive. Suppose the source moves towards the observer, V radial becomes negative. V radial becomes negative, right? So I can take down this, that the first point, note and the argument, first point work V radial becomes positive when the light source moves away from the observer. In the next one, V radial becomes negative when the source moves towards the observer. Full stop. Next point, note on the next point. See, frequency. We can write it in terms of wavelength also. Why? Because shorter wavelength with the longer wavelength can shift agutta. Longer with the shorter wavelength shift agutta. That's why we got red shift and blue shift. So then artha madkolake we can write this one clearly. So my dear students, for writing this, you know the formula. So you have a formula that nu is equal to c lambda. Nu is equal to c lambda, or lambda is equal to c, my dear students, nu by c. So this formula you have. Nimage relationship gottida frequency ಮತ್ತು lambda ಬಗ್ಗೆ. So the frequency is depending upon this lambda ಅಂತ ನಿಮಗೆ directly depend ಆಗಿರುತ್ತೆ ಗೊತ್ತಿಲ್ಲ. So ಹಾಗಾದ್ರೆ my dear students, how to write this one? How to write this formula? How it changes? It change ಆಗುತ್ತೆ. But we should be very careful while writing it. The formula. Yes. For the Doppler shift in terms of wavelength can be written as delta lambda divided by lambda gives you plus or minus V radial divided by C. So these are the two formulas which can be used for Doppler effect. So this is in terms of frequency and this is in terms of wavelength. Yes, this is all about red shift and blue shift. Now let us move towards observation of waves. So it means ಯಾವ ತರ ನಾವು light ray ನ wave ಆಗಿ represent ಮಾಡ್ತೀವಿ. So my dear students, ಈಗ ನಾನು ಸಿಂಪಲ್ ಆಗಿ ಈ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಏನು ಮಾಡ್ತೀನಿ, ಒಂದು ರೇ ಆಫ್ ಲೈಟ್ ಅಂದರೆ ಒಂದು ರೇ ಆಫ್ ಲೈಟ್ ಟ್ರಾವೆಲ್ ಆದರೆ ಯಾಕೆ ನಾವು ವೇವ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ಸೌಂಡ್ ವೇವ್ ಕೂಡ ವೇವ್ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ ಹೇಗೆ. ಸೊ ಮಾಡಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ಕ್ರಸ್ಟ್ ಅಂಡ್ ಟ್ರಫ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಲೈಟ್ ರೇ ಹೇಗೆ ಹೋಗ್ತಾ ಇದೆ, ಸೊ ಇಟ್ ಹಸ್ ಪಾರ್ಟಿಕಲ್ ನೇಚರ್ ಅಂಡ್ ಆಲ್ಸೋ ಇಟ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ವೇವ್ ನೇಚರ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಮಾಡಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ಸಿ ಐ ವಿಲ್ ಜಸ್ಟ್ ಶೋ ಯು ದ್ಯಾಟ್. ಸಪೋಸ್ ಸಿ ಹಿಯರ್, yes, it's not visible clearly. Yes. So when the light ray moves in a medium, it gives you crests and troughs ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ನಾವೇನು ಹೇಳ್ತೀವಿ, ಲೈಟ್ ರೇ ಅಂತ ಬಂದ ತಕ್ಷಣ, ಸೊ ಇನ್ ಕೇಸ್ ಆಫ್ ಸೌಂಡ್ ವೇವ್ಸ್ ಅಲ್ಲಿ ಕ್ರೆಸ್ಟ್ ಅಂಡ್ ಟ್ರವ್ಸ್ ಅಂತ ಹೇಳ್ತಾರೆ, ಕಂಪ್ರೆಷನ್ಸ್ ಅಂಡ್ ರೇ ಫ್ರಾಕ್ಷನ್ಸ್ ಅಂತ ಕರೀತಾ ಇದ್ದೀವಿ. But when we come towards the light, illenagtide light wave travel ಆಗಬೇಕಾದ್ರೆ ನಾವು ಕಂಪ್ರೆಷನ್ಸ್ ರೇ ಫ್ರಾಕ್ಷನ್ಸ್ ಅಂತ ಹೇಳಬಹುದು, ಕ್ರೆಸ್ಟ್ ಅಂಡ್ ಟ್ರಫ್ ಅಂತಕ್ಕಂಥ ವರ್ಡ್ನ ಜಾಸ್ತಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಬಟ್ ನಮಗೆ ವೇವ್ ಅಂತ ಯಾವ ಥರ ಬಂತು? ಸೊ ಇದನ್ನ ಕಂಪ್ರೆಷನ್ ಅಂತ ಕರೆದ್ರೆ ದಿಸ್ ಬಿಕಮ್ಸ್ ರೇಫ್ರಾಕ್ಷನ್. ಇಫ್ ದಿಸ್ ಇಸ್ ಅ ಕಂಪ್ರೆಷನ್, ದಿಸ್ ಇಸ್ ದ ರೇಫ್ರಾಕ್ಷನ್. ಕಂಪ್ರೆಷನ್, ರೇಫ್ರಾಕ್ಷನ್, ಕಂಪ್ರೆಷನ್, ರೇಫ್ರಾಕ್ಷನ್, ಕಂಪ್ರೆಷನ್ ಸೌಂಡ್ ಅಲ್ಲಿ ಕಲ್ತಿರೋದು. ಅದೇ ಥರ ಲೈಟ್ ವೇವ್ ಅಂತ ಬಂದ ತಕ್ಷಣ ನಿಮ್ಮೊಂದು ಡಾರ್ಕ್ ಬ್ಯಾಂಡ್, ಬ್ರೈಟ್ ಬ್ಯಾಂಡ್, ಡಾರ್ಕ್ ಬ್ಯಾಂಡ್, ಬ್ರೈಟ್ ಬ್ಯಾಂಡ್, ಡಾರ್ಕ್ ಬ್ಯಾಂಡ್, ಬ್ರೈಟ್ ಬ್ಯಾಂಡ್, ಡಾರ್ಕ್ ಬ್ಯಾಂಡ್, ಬ್ರೈಟ್ ಬ್ಯಾಂಡ್ ಅಂತ ಹೋಗುತ್ತೆ. ಅಂದರೆ ಲೈಟ್ ಬ್ಯಾಂಡ್ಸ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಸೊ ಇದನ್ನ ವೇವ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಯಾಕೆ ಬರೆದ್ವಿ ಅಂದ್ರೆ ಅಬ್ಸರ್ವ್ ಇದನ್ನ ನಾವೇನು ಮಾಡ್ಕೊಂಡ್ವಿ ಅಂದ್ರೆ ವೇವ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಬರೆಯೋಕೆ ಹೇಗೆ ಕಾರಣ ಅಂದ್ರೆ ಈ ಕಂಪ್ರೆಷನ್ಸ್ ಮತ್ತೆ ರೇಫ್ರಾಕ್ಷನ್ಸ್ ನ ನಾವು ವೇವ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ಈ ತರ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ವಿ. ಸೊ ದಿಸ್ ಈಸ್ ಆಲ್. ಹಾಗಾದ್ರೆ ವೇವ್ ತರಾನೇ ಟ್ರಾವೆಲ್ ಆಗುತ್ತಾ? ಇಲ್ಲ. ಅದು ಯಾವ ತರ ಟ್ರಾವೆಲ್ ಆಗುತ್ತೆ? ಕಂಪ್ರೆಷನ್ಸ್ ರೇಫ್ರಾಕ್ಷನ್ ತರ ಸೌಂಡ್ ವೇವ್ ಟ್ರಾವೆಲ್ ಆಗುತ್ತೆ. ಅದೇ ತರನೇ ಲೈಟ್ ವೇವ್ ಅಂತ ಬಂದ ತಕ್ಷಣ, ಲೈಟ್ ವೇವ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಅಂತ ಬಂದ ತಕ್ಷಣ they actually moves in this pattern. So wave ತರ ಇಲ್ಲಿ ಮೂವ್ ಆಗಲ್ಲ ಲೈಟ್ ವೇವ್. ಸೊ ಡಾರ್ಕ್ ಬ್ಯಾಂಡ್, ಬ್ರೈಟ್, ಡಾರ್ಕ್ ಅಂಡ್ ಬ್ರೈಟ್, ಡಾರ್ಕ್ ಅಂಡ್ ಬ್ರೈಟ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಆ ಬ್ಯಾಂಡ್ಸ್ಗೆ ನಾವು ವೇವ್ ನ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ವಿ ಗಾಟ್ ದಿಸ್ ಕೈಂಡ್. ಸೊ ಅದಕ್ಕೆ ನಾವು ಕಂಪ್ಲೀಟ್ ಆಗಿ ಲೈಟ್ ನ ವೇವ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ, ಸೌಂಡ್ ನ ವೇವ್ ಫಾರ್ಮ್ ಅಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ. ಸಿಂಪಲ್ ಆಗಿ we cannot write that the light is moving in this way. In but it is not enough. It is not enough. We should exactly know that how we got a wave. And the compressions, refractions into sound wave again. ಅದಕ್ಕೆ ನಾನು ವೇವ್ ಫಾರ್ಮ್ ನ ಡ್ರಾ ಮಾಡಿದಾಗ I got a sound wave. Similarly light ಅಲ್ಲೂ ಕೂಡ I got light wave. So ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡೋಣ. My dear students, see ಇಲ್ಲಿ ಒಂದು ವೇವ್ ಇದೆ, ರೈಟ್? ಸೊ ವೇವ್ ಇದೆ ಅಂದರೆ ಅದಕ್ಕೆ ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಇರುತ್ತೆ, ವೇವ್ ಲೆಂತ್ ಇರುತ್ತೆ, ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರುತ್ತೆ, ಟೈಮ್ ಪೀರಿಯಡ್ ಇರುತ್ತೆ, ಫೇಸ್ ಇರುತ್ತೆ. ಅದೇ ಥರನೇ ಎರಡು ವೇವ್ಸ್ ಅಂತ ತಗೊಂಡ್ರೆ ಪಾತ್ ಡಿಫ್ರೆನ್ಸ್, ಫೇಸ್ ಡಿಫ್ರೆನ್ಸ್ ಎಲ್ಲ ಬರುತ್ತೆ. ಬಟ್ ಈ ಕ್ಲಾಸಲ್ಲಿ ಫಸ್ಟ್ ಐ ವಾಂಟ್ ಟು ಶೋ ಯು ವಾಟ್ ಆರ್ ದ ಟೈಮ್ ಫಾರ್ ಈಚ್ ಅಂಡ್ ಎವ್ರಿ ಪಾಯಿಂಟ್ ಆಫ್ ದ ವೈಬ್ರೇಷನ್. My dear students, see here. See, I'm just going to show you. This is said to be the x and this is said to be the y axis. This is the origin. So for one complete cycle, the total period is time. Right. Similarly, for one complete cycle, the path, the phase is 2 pi. The phase is 2 pi. Right. I will just use to write the 2 pi like this. 2 pi. So ಹಾಗಾದ್ರೆ if time for one complete cycle is capital T, for one half cycle is it is T by 2. Then what is this point? T by 2 ನಲ್ಲಿ ಅರ್ಧ ಆಗುತ್ತೆ, right? So it means what happens? ಇದರಲ್ಲಿ ಅರ್ಧ ಬರುತ್ತೆ. How much you might get? It becomes T by 4. T by 2 by 2, it becomes 4. So now ಇದರಲ್ಲಿ ಏನಾಗುತ್ತೆ? It becomes off. So ಇಲ್ಲಿ ಏನಾಗ್ತದೆ? Reduce ಆಗ್ತದೆ. That between ಅಲ್ಲಿ it is becomes of 3T by 4. So now you can observe 1T by 4, 0T by 4, right? 1T by 4, 2T by 4, 3T by 4, 4T by 4. So time period ಯಾವ ತರ ವೇರಿ ಆಗುತ್ತೆ? T by 4 ಆಗಿ ಆಕ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ಈ ಪೊಸಿಷನ್ ಅಲ್ಲಿ 1T by 4, ಇಲ್ಲಿ 2T by 0T by 4, 1T by 4, 2T by 4, 3T by 4, 4T by 4. 4 by 4 cancel ಆಗಿ ಇಲ್ಲಿ T. And for one complete cycle, how much is the time period? It is capital T. Similarly, what is a phase? So if it is for one complete cycle, ಇದು 2 pi is the state of vibration ಅಂದ್ರೆ so ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಎಷ್ಟಿರುತ್ತೆ? It is pi. So I will just write here, this becomes pi, right? So at this point it is off of that pi, so it becomes pi by 2, right? Now it is varying in terms of pi. It is varying in terms of, see here it is you got 0 pi, 0 pi by 2, right? 1 pi by 2, right? 2 pi by 2. Here it is 3 pi by 2. So I am just going to write it as 3 pi by 2. So if you have a it varies as n pi by 2. At this point it is 0 pi by 2, 1 pi by 2, 2 pi by 2 gives you pi, 3 pi by 2, 4 pi by 2 gives you 2 pi. You should be very careful. ಯಾವ ಟೈಮ್ ಪೀರಿಯಡ್ಗೆ ಎಷ್ಟು ಫೇಸ್ ಇರುತ್ತೆ, ಯಾವ ಟೈಮ್ ಪೀರಿಯಡ್ಗೆ ಯಾವ ಸ್ಟೇಟಲ್ಲಿ ಪಾರ್ಟಿಕಲ್ ವೈಬ್ರೇಟ್ ಆಗ್ತಿರುತ್ತೆ. ಸೊ ಇಷ್ಟು ನೆನಪಿಟ್ಕೊಳ್ಳಿ. ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಡಿಸ್ಕಸ್ ಯು ಅಬೌಟ್ ದ ಫೇಸ್ ಡಿಫರೆನ್ಸ್ ಅಂಡ್ ದ ಪಾತ್ ಡಿಫರೆನ್ಸ್. ಹೋಪ್ ಯು ಆರ್ ಆಲ್ ಗೆಟಿಂಗ್. Just take down the notes and complete the concept on the day itself. Okay. Thank you, dear students.